So can someone tell me what is center of mass? What are the two people?
So it's where most of the mass of the body is concentrated.
Yes. That's it. So in this chapter, we'll be concentrating on topic center of mass and its motion. Okay. So first, center of mass is the point where whole mass of the object is concentrated. Right. Okay. If this is the case, then if I give you a system of points like this, M1 and M2, okay. Let's say these points from the origin are lying along x-axis, let's say at x1, 0 and x2, 0. Then where is the center of mass of the system? So if I ask you to locate the center of mass, so in other words, I'm asking, what is the formula for center of mass for two particle system which has the x coordinates as x1 and x2? What is the formula, guys?
x1 plus x2 by 2.
So XCM is equal to, it is not midpoint, it is M1 x1. So M1 x1 plus M2 x2 divided by M1 plus M2. So this is going to be the position of the center of mass. Okay. So how this can actually be derived is, for a small particle system, the center of mass and center of gravity is going to be the same. So I'll just show you how this has actually come. See, if I have mass M1, if I have another mass M2, that M1 will have a weight of M1g and M2 will have a weight of M2g. Okay. So let's say this is the origin. And I'm saying this is the point P where the center of mass is located. So if I take this as x1, 0 and this as x2, 0, then tell me one thing. If the system has the tendency to rotate, right? If the system has the tendency to rotate about point P, then M1G will try to put this whole system in which direction?
Anti-clockwise.
Yes. So M1G will have the tendency to put the system into anti-clockwise rotation. Then M2G will have the tendency to put the object into rotation in which direction?
Clockwise.
In the clockwise direction. So there will be clockwise moment and anti-clockwise moment. So what is the clockwise moment that is going to act? That is M2G into perpendicular distance. We know that moment is force into perpendicular distance from the axis of rotation. So M2G into, so if this is origin, guys tell me, how much is this distance? How much is the distance that I've drawn? The one which I marked with red. It is x1. What is the distance from origin to point P? X. Distance from origin to point M2 is x2. So what will M2P distance be?
x2 minus x.
What will this distance be? X minus x1.
Minus x1.
So m2g into perpendicular distance is x2 minus x1 is equal to m1g into this distance is x minus x1. So g will get cancelled. So from this I can get m2x2 minus m2x1 is equal to m1x minus m1x1. So m1x1 x2 minus x1. So m1x1 to the other side, m2x to the other side, which implies it is m1x1 plus m2x2 is equal to m1 plus m2 whole multiplied with x. So which implies x is equal to m1x1 plus m2x2 divided by m1 plus m2. If it is an n particle system, then it will be m1 by 1 plus m2y2 plus m3y3 so on till m1x1 plus m2x2 plus m3x3 so on till mnxn divided by total mass. Did you guys understand? So this is the center of mass for a two particle system. Means in a system where there are point masses that are present. Just a minute, guys. Is there any doubt till here?
No, sir.
Make a note of this. Write it down. Done.
Yes, sir.
No risk. So for n particle system, I hope you guys can write down the formula. So x coordinate of center of mass will be m1 x1 plus m2 x2 plus so on till mn xn the whole divided by sum of all the masses m1 plus m2 plus so on till mn. Similarly, when you talk about the y coordinate of center of mass, that will be m1 y1 plus m2 y2 plus so on till mn yn the whole divided by sum of all the masses. Similarly, z coordinate will be m1 z1 plus m2 z2 so on till mn zn. Okay. So we will do a simple problem based on this concept. So just do the first problem. In a HCl molecule, the separation between the nuclei of the two atoms is about 1.27 angstrom, where one angstrom is 10 power minus 10 meter. The approximate location of the center of mass from the hydrogen atom, assuming the chlorine atom to be about 35.5 times massive as hydrogen is. So you have HCl. So it's a dipole. The distance of separation between them is 1.27 into 10 power minus 10. The mass of hydrogen is m. The mass of chlorine is 35.5 m. So they're asking the approximate location of the center of mass from hydrogen atom. So here I gave you a formula, right? M1 x1 plus M2 x2 plus so on. What do you mean by those x1 x2, all those things?
Distance from origin.
Distance from origin. So whenever you want to define the center of mass of a particular system, right, what are the first and the foremost step?
Choose a point as origin.
You need to choose the origin. So in this question, according to the question they have asked, it is smart for us to choose which point as origin.
Center of mass.
No. Look at the question. Assuming chlorine to be about 35.5 times, the approximate location of the center of mass from hydrogen atom. Indirectly, he has told you.
Hydrogen atom, sir.
You take hydrogen atom itself as this origin. If you take this as 0, 0, then this point will be 1.27 into 10 power minus 10. Okay. Now what will be the x? If I take this point as x cm, then the x coordinate of center of mass is equal to m into 0 plus 1.27 into 10 power minus 10 into 35.5 times m, the whole divided by 36.5 times m. Right. So if you calculate, obviously you are going to get the answer. The calculation part I'm leaving it to you. Okay. So here, one point I would like to mention is, when you calculate the center of mass, where do you think it will be close to? To which point do you think it will be close to? Will it be close to hydrogen or will it be close to chlorine?
Chlorine.
Reason?
Heavier mass.
Yes. So please make a note, everyone. The center of mass is always closer to the point which has more mass. Center of mass is closer to the point with heavier mass. Okay. Harini, can you tell me the proof for it? Why is it so? How do we know that? How do we prove that it is close to the center, heavier mass? You can try if you do. So what we can do is we can take a two particle system, M1, M2. I'm saying M1 is greater than M2. Okay. Let's say the distance of separation between them is R, and from M1, let me say R1 is the distance of center of mass, right? So if I use the concept of torque, that is the principle of moments, what can I conclude?
Clockwise
M1,
moments is equal.
yes, M1G into R1 will be equal to M2G into how much?
R minus R1.
R minus R1. So G and G will get cancelled. So M1 R1 will be equal to M2R minus M2R1, which implies M2R is equal to M1 plus M2 into R1. So R1 will be equal to M2 divided by M1 plus M2 into R. Right? Then what will R minus R1 be? R minus R1 will be M1 divided by M1 plus M2 into R. Okay? Because R by M1 plus M2 and R by M minus M1, R by M1 plus M2 in both the cases will be common. So if I take the ratio of R1 and R minus R1, I get M2 divided by M1. Is M2 divided by M1 less than 1 or greater than 1?
Less than 1.
It is less than 1 because M1 is greater than M2. So if I take this as A, P and this as P, so from this can I conclude R1 is nothing but AP. R minus R1 is nothing but BP is less than 1, which implies AP is less than BP. From this we can conclude that center of mass is always closer to the one with heavier mass. It's always closer to the particle with heavier mass. Okay, this is a very, very important point. Make a note of it. Maybe this has to be used as a information in some part of the problem where they will not mention all these things. So please make a note of all these things. Done.
Yes, sir.
Okay. So now we'll go about the motion of center of mass. Okay. So I'm taking the x coordinate of center of mass as m1 x1 plus m2 x2 plus so on till mn xn the whole divided by m1 plus m2 plus so on till mn. Right. Then if I differentiate this, okay, with respect to time, then I will get 1 by sigma m into m1 into derivative of x1 with respect to time plus m2 into derivative of x2 with respect to time plus so on plus mn into derivative of xn with respect to time. So dxcm by dt gives us what?
Velocity.
Velocity of whom?
Center of mass.
Center of mass.
So velocity of the center of mass is equal to 1 by total mass into mass of each object with multiplied with its velocity is going to give us,
Linear moment.
yes. So P1 plus P2 plus so on till Pn. Okay. Only difference is here we are going to write it in the form of vector. So P1 vector plus P2 vector plus so on till Pn vector will give us the linear momentum of the center of mass. Because I took, see what I did is, sorry, I took this total mass to the other side. So total mass multiplied with velocity of center of mass. Where is the total mass said to be concentrated? At its center of mass, right? So total mass multiplied with velocity of center of mass will give us the linear momentum of the center of mass. So this will be the answer. Am I clear, guys? So when there is a question stating find the linear momentum of the center of mass, this is how we approach. Clear?
Yes, sir.
Okay. Now comes the next important point, that is differentiating 2 with respect to time. Then I'll get dpcm by dt is equal to dp1 vector by dt plus dp2 vector divided by dt plus so on plus d Pn vector divided by dt. So what is this thing, guys?
Force.
It is the force. So F is equal to so on till Fn vector. This force I can also write it as m into ACM is equal to F1 vector plus F2 vector plus so on till Fn vector. What is this actually?
External force
This
experienced by the center of mass.
is nothing but Newton's second law. So till now, when we solved a problem, let's say there is a block that is moving, okay? We told the acceleration of the block is F. Let's say I'm applying a force which is sufficient enough and its mass is m. Then we are writing F is equal to ma, right? This acceleration we are trying to talk about is nothing but its center of mass, because logically think, no, this block also would have been made up of many particles. So what do you mean by m? The whole mass being concentrated at its center. So when you apply this force on a particle, that force will be equal to mass of the particle into whatever is the acceleration of the center of mass. This is what is Newton's second law. We'll use more of this concept in the next chapter. Am I clear?
Yes, sir.
Yes, sir.
So this is all about the center of mass and its motion for what? For a particle system. What if you have a continuous system? Okay. So when you have a continuous system, that is when you have extended objects. Okay. For example, let's say I have a rod of length L and uniform mass throughout its length. Okay. Then where is the center of mass of the system located?
In the center.
It's exactly at the center because it's a regular shape. But is this a point mass or an extended mass?
External.
Extended.
Right. So when it is extended mass, can we use this formula? Can we use all these formulae? M1x1 plus M2x2 and
No,
all
sir.
those things. So it is applicable only for point masses. So what we need to do is we need to understand what is the formula for extended masses. So write it down. X coordinate of center of mass is equal to, see, for particle mass it is m1x1 plus m2x2 plus so on till mn xn, right? The whole divided by m1 plus m2 plus so on till mn. Now for extended masses it is like this. Instead of m1 x1, what you're going to do is you will integrate x with respect to dm divided by integral of dm, because integral of dm is going to give you the total mass. Similarly, what will be the y coordinate of center of mass, guys? Integral of y dm divided by dm. Sorry, integral of dm. Z coordinate of center of mass will be integral of z dm divided by integral of dm. So this will be integral of x dm divided by capital M, where capital M is the total mass. This will be integral of y dm divided by capital M. This will be integral of z dm divided by capital M. Make a note of this. I'll tell you an important point. Done?
Yes, sir.
Write it down. Steps to be followed to calculate center of mass of extended object. So whatever steps I'm going to give here, you can follow the same steps throughout physics. Throughout your physics, wherever you need to do integration, you can follow the same steps. Only difference is going to be, in this case, it is going to be about center of mass. In other case, you just need to replace them with the respective formula in that context. Okay. So first, define, 1 minute. Define the type of mass density. Second, consider a small mass dm from a point which is taken for reference. Okay. Third, consider a small mass dm so I've written already. Consider a small mass dm from a point. Okay, one small correction. Consider a small mass dm at a distance x. At a distance x from a point which is taken for reference. Okay. Then define dm in terms of mass density and x. Fourth, apply formula, integrate with proper limits. So this is also like applications of integrals. Okay. Now see. Find the center of mass of rod of uniform density and length L. So I've considered a rod of length L. So first step, what is that we need to do? Define the type of mass density. In this case, what is the type of mass density that can be defined?
Linear mass density.
So lambda, yes, that's right. Lambda is equal to m divided by L. By the way, I hope everybody knows what are the three types of densities. Like how we have learned in charges in first chapter, I would have explained, right? Q by L, Q by A, and Q by V. Linear charge density, linear surface charge density, and volume charge density. If you replace Q with mass in the numerator, it will become linear mass density, linear surface mass density, and volume mass density. So lambda is equal to m divided by L. Second step, consider a small mass dm from dx from a point which is taken for reference. So let me take this as the reference point. From the reference point, I'm going to consider a small element of mass dm. So when I say it's a small element, its thickness is also small. Let's say it's dx. And its mass is dm. Third, define dm in terms of mass density and x. So dm is always equal to mass density multiplied with thickness. Okay, actually it's not always. I'm sorry. So lambda is equal to m by L. Can I write lambda is equal to dm by dx also? Guys, did you understand why I wrote dm by dx? Because it is uniform density. So which implies dm is equal to lambda times dx. Is there any doubt in this step?
No, sir.
Third, apply the formula. So what is the formula? X coordinate of center of mass is integral of x dm divided by the total mass. So 1 by m into integral of x into, what is the value of dm, guys? It is m by L into dx. Integrate with proper limits. So this x has to be ensured that it covers the total length of the rod. So if this point is taken as 0, 0, the total length of the rod is L. So integrated from 0 to L, right? So 1 by m into m divided by L into integral of x dx between 0 to L. M and m will get cancelled. It is 1 by L into integral of x dx is x square by 2. And you substitute the limit, it will become L square by 2. L and L will get cancelled. Answer would be got it. So if you are done copying, we are ready to do problems in this chapter. Shall I start?
Yes, sir.
Listen. There is a 2 kilogram block and a 3 kilogram block that are moving along the x-axis. At a particular instant, the 2 kilogram block has a velocity of 3 meters per second and 3 has velocity of 2 meters per second. The velocity of center of mass at that instant is. It's a simple formula. M1v1 plus M2v2 divided by M1 plus M2. So M1 is how much? 2. Into velocity of that block is 3 plus M2 is 3 and the velocity of the block is 2 divided by M1 plus M2, that is 5. So 6 plus 6, that is 12 divided by 5 centimeter per second. So answer is none of these. So just give me a minute. Let me check the solution. The answer. I don't have answers in my hand now. Yeah, but it's none of these. From the question we can understand. Yes. So let me see what are the questions you can do. The distance between carbon atom and oxygen atom in a carbon monoxide molecule is 1.1. Given the mass of carbon is 12 mu, the mass of oxygen is 16 mu. Calculate the center of position of the carbon dioxide molecule. So carbon monoxide molecule. So here, if you read the question, they have given different options: 6.3 angstrom from carbon atom, 1 angstrom from oxygen atom, something like this. Right? So it's not easy for us to calculate, like easy for us to find out from options itself. I thought we can find from options, but it's not working. So what do you need to do? So when they ask you from carbon atom, what are we supposed to do? We have to take carbon as the reference point and then solve it. Right? Similarly, if they ask from the oxygen atom, oxygen is taken as a reference point and then you solve it. If you take any one of the points as a reference point, let's say from carbon, if it is at a distance x, from oxygen, it will be at a distance of d minus x, where d is the distance between carbon and oxygen. That part I'm leaving it to you. So fourth also homework. Let's do the fifth one. The center of mass of a triangle shown in the figure has the coordinates. Guys, do it immediately and tell me.
Sir, option B.
Option?
B, sir.
Second option.
Yes, sir.
No. How did you find?
Sir, I just did that integration, sir.
Oh, you took, but here you can't do that integration directly. So you did for x separately and y separately.
Oh, sir, you have to, okay. You have to use area, okay, sir.
1 minute, just a minute. I think the answer given here doesn't match. So the question itself is ambiguous. They're asking center of mass of the triangle. So triangle means it has to be a continuous system. So I'm just wondering if they're talking about the whole triangle or there are masses placed anywhere. This question is actually ambiguous. You can't solve it. If at all you take it as a triangle, how you are going to solve it? Find that out. I'll give you the hint. See,
Sir, the density will be mass by area, no, sir?
yes.
Sir, so with that you solve separately and have area in the denominator and cancel out, no, sir?
Yes, you have to do that, but we have to think. Here, the challenging part is how are you going to take the area? See, for example, if I consider a small strip like this, okay. So let's say this is at a distance x and its thickness is dx. Here, I don't think it is easy for us to solve. So this is y. So integral of x into dm is going to be m by area. What is area? Half into b into h. Half into m into b into h into dx, or the whole divided by total mass. So m and m will get cancelled. 2 divided by bh into integral of x dx. But actually, it will not be x dx, rather, it will be x in y into dx. So here, the challenging part is we can't. We have to find the relation between y and x, so we need to involve trigonometry. Okay, I'll think about this. This problem is not like how we are doing. So this question is ambiguous. We can leave. So try the next one. So two bodies of mass 2 and 4 kilogram are moving with velocity 2 meter per second and 10 meter per second respectively along same direction. Then the velocity of the center of mass will be.
Option B, sir.
Sorry?
Option B,
Option
sir.
B, sir.
B, second option. No? Yeah, that's right.
Yes, sir.
Next one. 4 particles of mass m, 2m, 3m and 4m are arranged at the corners of a parallelogram with each side equal to A, and one of the angle between the two adjacent sides is 60 degrees. The parallelogram lies in the xy plane with the mass m at the origin and 4m at the on the x-axis. The center of mass of the arrangement will be located at. How to proceed? Anybody who can tell me the idea? So 4 particles of mass m, 2m, 3m, and 4m are arranged at the corners of a parallelogram. So each side of the parallelogram is how much? 6. Side A. The angle between their sides is 60 degrees. The parallelogram lies in the xy plane with m at the origin. Then 2m will be here, 3m will be here, then 4m also on the x-axis. Then this will be y-axis. Okay, so since this is a particle system, right? What do we need? We need the coordinates of the points. You guys tell me. What is the x value of this? What is the y value of this? A simple right angle triangle. They asked a simple question. This is x comma y, this is x and this is y. What is the value of x and y? So x will be a cos 60, y will be a sin 60. What will be the coordinates of 3m? Make it fast and tell me.
Three a by 2 root 3a by 2.
Now it is easy to calculate. I hope you understood what I did. I multiplied the mass with corresponding x coordinate. 4m plus m, 5m, 5m, 7m, it will be 10m. So m will get cancelled. 4a plus a plus 9a by 2 divided by 10. So 5a plus 9a by 2 by 10. How much is it? 19a by 2 divided by 10, that is 19a by 20. (19a by 20 is 0.95. So option should be B. Right, other thing you need not do. Guys, are you able to understand?
So how did we find coordinate for B?
How did we find coordinates of 3M? So it's same. Again, drop a perpendicular. This distance is already A, and this will be A cos 60. So A plus A cos 60 is A by 2. So A plus A by 2 is 3A by 2. Y coordinate will be the same because it's of the same height from the x-axis. Aditya, did you understand?
Yes, sir.
Yeah. Okay. Look at the 8th one. No? So 3 identical metal balls, each of radius r, are placed touching each other on a horizontal surface such that an equilateral triangle is formed. When the centers of the 3 balls are joined, the center of the mass of the system is located at. For a triangle, where is the center of mass?
The point of intersection of medians.
Point of intersection of?
Medians.
What is the name of that point?
Centroid.
It's called centroid. Okay. So now what we can do is, I just got an idea. The 5th problem is there, right? We will approach in the reverse. So this is also a triangle. Where will the center of mass of this be? It will be at the centroid. Right. So this coordinate is B comma 0. This coordinate is 0 comma h. If you find the centroid of this triangle, what are you going to get?
B by 3, comma H by 3.
That's right. Srivatsan, got it? Right. So 9th one. 2 bodies of different masses, 2 kg and 4 kg, are moving with velocities towards each other due to mutual gravitational attraction. What is the velocity of their center of mass? Find it fast. Do the 10th one. Guys, I hope you're doing it on the other side. Since these are easy, I'm not speaking much. So 2 particles of masses m1 and m2 initially at rest start moving towards each other under their mutual force of attraction. The speed of the center of mass at any time t when they are at a distance r apart. So how do we approach? So you guys tell me, how do we start approaching? See, whether it is right or wrong, just speak up.
So first we need to find the center of mass.
Okay. But they have asked the speed of the center of mass. No, actually, we have a formula for speed of center of mass. That is VCM is equal to m1 v1 plus m2 v2 by m1 plus m2. Right.
Sir, but then speed is not given, sir.
I've circled something. two particles are initially at rest, so what will happen to the velocity of center of mass?
0.
You need not do it all. That is why it's been asked. Okay, so they are initially at rest, their velocities are 0. So when you are going to calculate the velocities, the speed with which they are going to move, it is going to be 0. Okay, because, and one more logic is, okay, here they have not told gravitational force. So it is because of the mutual force of attraction they are moving. So the force exerted by 1 on 2 is the same as the force exerted by 2 on 1. So from here also we can say that it is not going to accelerate. So that is why, since the initially the system was at rest, finally also the system will be at will be having that is the velocity of the center of mass is still going to be 0. It is not going to move. So maybe the particles are moving. The particles will move in such a way that the velocity of the center of mass is going to still stay at the same location. Okay. 11th question. Let's try this. Is there anyone having doubt with 10th? Is there anyone who is not clear?
No.
No, sir.
So there is a T-shaped object. Dimension shown in the figure is lying on a smooth floor. A force F is applied at the point P parallel to AB. Show that the object has only translational motion without rotation. Find the location of P with respect to C. Oh, not show that such that. Okay, sorry. The force is F is applied at a point P parallel to AB such that the object has only translational motion without rotation. Find the location of P with respect to C. So C is supposed to be considered as origin. C. Yesterday I told you, right? In the previous class I told you, every question will have data and a hint. So here the data that is given is the length of the objects, the points, and force F. So all these are given data. So your final answer can be in terms of all these given data. But for us to approach the question, what is the hint we need to use from the question? So the force F is applied on an object such that it has only translational motion without rotation. What is the meaning of this, guys? When will the object tend to rotate?
So that means in this case, clockwise moments is equal to anti-clockwise moments. That
That's
means
right.
the point P is center of mass.
That's right. Very good. So please make a note. If you don't have this information already, please make a note. If the force is applied on an object about the axis of rotation, okay. If the force is applied on an object through the axis of rotation, the system will not rotate. There is a reason why I'm using axis of rotation. Please make a note, then I'll explain. So if force is applied exactly through the axis of rotation, the system will not rotate. Okay. So when I talk about axis of rotation, there are two types of axis we can define. One is natural, and the second is instantaneous. Okay. So here I'm talking about the axis of rotation, which is natural, not the instantaneous one. Instantaneous one, the system can rotate, whereas the natural one, it can't rotate. Now comes the question. So one small correction in the statement I gave you. Force applied through the natural axis of rotation will never. So please add the word natural. Force applied through the natural axis of rotation, that the system will not rotate. So what do you mean by natural axis? Natural axis is the point which is passing through the center of mass. Instantaneous can be any point. So when force is applied about the center of mass, it will not rotate. That is an indirect way to understand. Okay. So find the location of P with respect to C. How do we proceed? Now, do you have an extended mass in your hand or point mass?
Extended.
You have extended mass. But the advantage with this kind of a system is the extended mass system can be converted into point mass system by using the basic definition of center of mass. So if I take the rod AB, where is the center of mass of it going to be located
At its center.
at its center, right? So what we can do is for AB, okay, I'm taking the same diagram. See, I'm using a green color dot. For AB, the center of mass will be here. So let me call this mass as capital M. Okay. For the rod which is vertical, where is the center of mass going to be? At its center. So if I call guys, are you able to understand this?
Yes, sir.
And where is the force F applied? Somewhere over here. So they are asking what is the distance from C to the point where this force is applied. Now tell me, this whole system can be converted to a two-particle system such that with respect to the point C being taken as origin, this capital M is at a distance of L and this point is at a distance of how much value?
Two L.
Very good. It is 2L because you can ask me, what about the thickness? Here when you say, when you take it as a thin rod, its thickness is ignored, so it's 2L. So this point is origin. So what will be the coordinate of this point? 0, L, and this point will be 0, 2L. Now can you find out? So y coordinate of center of mass will be m into L plus m into 2L divided by 2m. So 3 ml divided by 2m, this will get cancelled. It will be 3L divided by 2. Did they mention anything about their densities? See, actually, I've considered something. What is that I've considered? What is not given in the question and what is that I've considered?
The mass, sir.
The mass is actually not given. Right? So if at all this question comes in exam, you will get marks. Because they have not mentioned anything about their density, nor they have mentioned anything about where this vertical rod is actually hinged with respect to the base. Okay, nothing is clear. We don't know whether they are collinear also. We have no information, right? So if I take this as M and this as M, I'm getting 3L by 2. But if you take them to be of different masses, there might be other options also that will come out. You're able to understand? So to be honest, this question is having insufficient data. But keeping all those things aside, did you guys understand the method to approach this kind of a problem? If there is a proper data given. So when though you have an extended mass, you can always convert it to a point mass system by taking the center of mass of individual component. Component means AB, the horizontal rod is one component, vertical rod is one component. Am I clear, guys?
Yes, sir.
Yes, sir.
So let's do the 12th one. Tell me. Two spheres of masses 2m and m are initially at rest at a distance r apart. Due to the mutual force of attraction, they approach each other. When they are at separation of r by 2, the acceleration of the center of mass of the spheres will
Then 0.
be. It's 0. Same logic. Initially at rest, the acceleration of the center of mass will still be 0. All of the data they'll only give to confusion. 13th. Mass is 8 kilogram, 2, 4 and 2 are placed at the corners ABCD of a square ABCD of diagonal 80 centimeter. The distance of the center of mass distance of the center of mass from A, that is from the 8 kilogram block. I hope this you can do. So in this problem, there is no physics. It's all about geometry. I'm leaving this to you. This can also be done as homework. Do the 14th one. What do I do? Integral of xtm divided by the total mass. So can I write it as integral of x into lambda dx? Guys, by now I hope you understood that dm is lambda dx. By
Yes, sir.
this I can write as integral of dm. That is nothing but integral of lambda dx. Right? Now can you guys integrate it? Lambda is 2 plus x. So numerator will be 2x plus x square dx. Denominator will be 2 plus x dx. So where should we integrate it from? 0 to so dx is the limit.
0 to 3, sir.
Yes, that's right. So what I've done is I've taken the reference point as left one. If this is dm, this is dx, this distance is x. Okay. So where is the value of x going to vary from? It is going to vary from 0 to 3. So why 3? Because the length of the rod is 3 meter. So here also 0 to 3. Can you integrate fast and tell me what is the answer?
Twelve by 7.
That's right. So we'll do some previous year problems. I'll just give you the outline. You guys tell me. I mean, we'll just discuss the hints. Problems you guys solve it. So tell me how to do the first one. 3 particles of masses 50 gram, 100 gram, and 150 gram are placed at the vertices of an equilateral triangle of side 1 meter. The xy coordinate of the center of mass. Can you guys do this? So it's a 2019 question. It is 0, 0. This point will be 1, 0. How to find the coordinates of this vertex space? it will be 0.5 comma. Why is it 0.5? Because that point is going to be at the midpoint of 0 and 1. 0.5 comma. If I take this as h, then h divided by 1 is how much? Sine 60. So this will be root 3 by 2. So you have three values. You can find the center of mass. So tell me whether the logic is clear. Solving part, you do it later. Let's not waste time.
Yes, sir.
So there's a very simple problem, right? Next. A uniform rectangular thin sheet ABCD of mass capital M has a length A and breadth B as shown in the figure. If the shaded portion HBGO is cut off, then the coordinates of the remaining part of the system will be. Guys, please make a note. To find the center of mass of a system after removing an area from it. Yes. I'll take x coordinate of center of mass is equal to a1 into x1 minus a2 into x2 divided by a1 minus a2, where a1 is area of total object, x1 is the center of mass of total object, a2 is area of removed portion, x2 is center of mass of removed portion. So if you guys have made a note of it, I'll explain how to do this problem.
Noted, sir.
Okay. So similarly, if you want to find the y coordinate, you need to do the same thing. A1, y1, a2, y2, all those things. Okay. This is a rectangle, right? So what are the dimensions of the rectangle? A, and this part is B. So A1 is how much? You guys tell me. A1 is the area of the total object. That is
AB.
AB. What is A2? Correct? Huh? A
Sir,
by
it's
2 and B by
AB
2 is
by
different. Oh, sorry. It is AB by 4. So what is x1? The question is, where are you taking the origin as? See, the smarter way to do all these problems is take any one of the center of masses itself as the origin. So if I take the central, see in this question, they are fortunately given it. Some they will not give. So I suggest you to take the center of mass of the bigger portion as the origin. So x1 will be x1 comma y1 will be 0 comma 0. Then what about x2 comma y2? Where will the center of mass of the removed portion be with respect to the point O considered as origin?
A by 4.
It's not A by 4. Oh, sorry, A by 4. Yeah, what you told is right. A by 4 comma B by 4. Right? Now can you apply the formula and tell me what is the answer? Oh, guys, 1 minute. I'm sorry. They have given it. I didn't see it in the question. So they have given this point as origin, because that's why I was wondering. They didn't ask about which point. So x1 comma y1 will be how much? It will be a by 2 comma b by 2. Then x2 comma y2 will be how much? To already existing a by 2, you need to add a by 4. That will be 3a by 4 comma 3b by 4. Now solve the problem. Tell me what is the answer. So x coordinate of center of mass is 5a by 12. Similarly, I think if you calculate y coordinate also, you will get 5b by 12, because you have the similar kind of points. Guys, am I clear?
Yes, sir.
So third one. 4 particles A, B, C, D with masses MA is equal to M, MB is equal to 2M, MC is equal to 3M, and MD is equal to 4M at the corners of a square. They have accelerations of equal magnitude with directions as shown. The acceleration of the center of mass of the system is. So A1 vector is how much?
A minus I cap.
Yes. A2 vector will be. So I'm just going in the clockwise order. This is A2. So A3 will be AI cap, A4 will be A minus J cap. I hope you guys can solve this problem. Just substitute it and you will get the answer. Okay. Next is, they're asking the position vector of the center of mass of R of an asymmetric uniform bar of negligible area of cross section. So this problem, what is the idea? For 2m, consider its center of mass. For m, consider its center of mass. And between 2l and l, consider its center of mass. Right? Write down their coordinates in terms of x and y. Once you write the coordinates, apply the formula, then write r vector. So you'll get x coordinate and y coordinate. Let's say x coordinate is coming out as a, y coordinate is coming out as b. Then r vector will be ai cap plus bj cap. Instead of a cap and b cap, I cap and j cap, they will be x cap and y cap. Guys, am I clear with this? I hope that part you can do it. I didn't get response. So listen, then what will be the coordinate of center of mass of the first rod?
L, L.
How much is it? L by 2, comma. Oh, they have given this itself. This whole rod is of length L, right? Then it should be L, comma L. So what are the coordinates of 2m? It is L, comma L. What are the coordinates of the center of mass of M, the vertical rod?
2L, L by 2.
That's right. 2L, comma L by 2. What are the coordinates of third mass M?
3L, 0.
It is not 3L, no.
Oh,
It is here. See, this distance is L by 2. If you take this as origin, so L plus L by 2. 3L by 2, comma 0. Now can you calculate? So 2m into m, 2m into L plus 2m into L plus 3L by 2 into m. That will be the x coordinate. Sorry, it is 2L by L, 2L plus L by 2. It is 5L by 2, right? 5L by 2, comma 0. Because this distance is 2L. This is 2L and this distance is L by 2. So 2L plus L by 2 is 5L by 2, comma 0. I hope you can do this. So I'll finish it off. See. 2m into L plus 2L into m plus 5L by 2 into m, the whole divided by 2m plus m, that is 4m. So m will get cancelled everywhere. 2L plus 2L plus 5L by 2 divided by 4. So 4L plus 5L by 2, how much is that? 13L by 8. So 13L by 8 is the answer. So first one is the answer. Okay. So just confirm if you're clear.
Yes, sir.
Yes, sir.
Yes, sir.
So that's how we do. So with this, we can wind up. Just give me a minute.